So teacher Kirsty tells me that you guys started with cross simplifying in your lesson on Tuesday. How did that go? And can anyone tell me like something that they remember from it, or who's feeling brave? Who can give me an idea of what happened in your lesson on Tuesday? Oh, we're all feeling quiet today. It went good. Okay, well, it's good that it went good. So are we happy with cross simplification? Do we understand what we're doing when we're doing cross simplification? I'm just going to pop a little example up here. Let's see how we go with it. Okay, it seems like it's wanting to sync every time I write something. So we're going to have to do this the best we can at the moment. Because that's not going to get us very far. Let's have a look at one of these ones. Let's just look at this 5/8 times 2/3. So I don't want you to follow the method that's happening down here. I want you to just look at that 5/8 and that 2/3. Who thinks that they can tell me how we could go about doing a cross simplification with that? What could we do? How could we do this? Emichle, yes. Okay, I've asked to unmute. You should be able to talk.
Afternoon, ma'am.
Hi, how are you?
I'm good, and you, ma'am?
I'm very well, thank you. Okay, how on earth would I go about doing this?
So, ma'am, first you would have to cancel out. So you would say 2 goes into itself once,
Okay,
and then it goes into 8 4 times.
okay, beautiful. And then where would I go to from there? How would I
Ma'am,
solve it?
then you say 5 times 3.
Oh, think about it like this. Don't panic because we haven't done multiplication yet, so you aren't doing anything wrong. Look at where I've drawn these little blue lines. Think about how they could help you. What could I do there?
Oh, yes. 5 times 1 is
Good,
5.
beautiful.
That's the numerator. And then the denominator will be 4 times 3, which is 12.
Beautiful. Yay. Nice job. Great work. Woohoo. Okay. That was great. I'm so stoked. So that is what we're doing here. So we're going to be focusing on multiplication today. If you have a look, they get to the exact same point in a much longer way without doing cross simplification. So all that happened was we said the 2 together. So we said our numerator times our numerator, 5 times 2, which is 10, 8 times 3, which is 24. And then we landed up with this fraction of 10/24. So this dude over here. But 10/24 can be simplified, and it can be simplified down to 5/12. If we do our cross simplification right in the beginning, we don't need to simplify our fraction at the end. So it's just like a nice, easy way of keeping our numbers small and making it a little bit easier for us as we move on. Okay. All right, let's have a look at these questions over here. What type of fraction are these where we have this number and then we've got a fraction next to it? They have a special name. Okay, Kungawa, can you help me? What type of fraction are these? Oh, I can't hear you. Just check that your if you're using a headphone, just check that it's plugged in. I'm gonna have to go on to our next person. Okay, I'm seeing mixed fractions. That's great. Good. Okay. Sorry for the hands. Your answers in the chat are perfect. They are definitely mixed fractions and mixed numbers. And in junior school, you're sort of encouraged to use mixed numbers. It's like the thing that they want you to do. And then you get to high school And basically we tell you to forget about that. And we want to only work in improper fractions. So improper fractions are when we have a top-heavy fraction. So that's when our numerator is bigger than our denominator. So if you look here, we've got the 7, and that is bigger than a 3. Okay, so that makes this an improper fraction. Who thinks that they can tell me? We'll actually, let me just do this quickly for you, because then we can get going on to some of the other cool stuff. To move from a mixed number or a mixed fraction into an improper fraction, all we have to do is we follow a very simple set of rules. So we say our denominator times by our big number. So that would be 2 times 3, which gives us 6. And then we add our numerator, which gives us 7. And the denominator stays the same. So as you see, it was a 3 over there, it's going to stay as a 3 over here. So it's same process over here. We're going to say 2 times 3, which gives us 6, and 6 plus 1, which gives us 7. And then we would have 7 over 2. Okay, so whenever we're doing multiplication of fractions, the first thing we want to do is we want to turn them into improper fractions. That is our first goal. Oh, sorry guys, that's my dog. Okay, once we've done that, we can then multiply our numerators and we can multiply our denominators. So here we're saying 7 times 7, which gives us the 49, and 3 times 2, which gives us 6. Now, in this question, it was changed back to being a mixed number. If you're working in story sums, or you're working with like trying to find how much is left over, then sometimes it's helpful to go back to a mixed number. But if you're just working in a normal sort of mathematical sum, you can just leave it as an improper. It's like the fun thing about high school. You can just leave it as 49 over 6. Okay. Does anyone have questions about changing from a mixed to an improper and then this multiplication process? Or can we go into some questions? Yes, Amikle, how can I help?
Ma'am, let's say in a test there's a multiplication sum with fraction
Mhm.
terms. And so then let's say at the end of the sum you get an improper fraction. And let's say you don't simplify it to be a mixed number. Will it be marked incorrect, or you still get the mark?
So that is completely dependent on your maths teacher. When you get to the higher grades, so definitely from grade 10 up, you would always leave it as an improper fraction. So you would leave it as the 49 over 6. But some of your teachers might be sort of asking you to change it back to a mixed number. So if your teacher pushes that, then definitely do what they suggest. Generally, though, you can leave it as an improper and it would still be correct.
Okay. Thank you, ma'am.
No problem. Okay. So we did some cross cancelling already, so we can have a look at these questions over here. Okay. Is it okay if I have 3 on the board at the same time? Does that work with you guys? You can give me a little thumbs up or a thumbs down. Yes, Bree, hello.
Hi, ma'am.
Are you going to answer a question for me?
Oh, is it okay if I ask a question instead?
Absolutely. Ask away.
Ma'am, about the last example that you gave us, I saw that the answer was like 8, 1 over 6. So I'd like to know how the answer did have a remainder, but like how did it turn into a mixed fraction?
Okay, yeah, and that's a great question. Okay, so basically what you're wanting to do is you're wanting to see, so if you take your calculator does some cool things for you. If you put 49 over 6 in your calculator and you just push equals, it will actually make it into this for you, which is quite cool. But let's go sideways. The easiest thing to do is to think, how many times can 6 go into 49? So 6, 12, 18, 24, 30, 36, 42, 48. And then if I go another one, I go higher than 49. So 6 goes into 49 8 times. So that's where this 8 whole number is left. And it went in 48. So that I'm left with 1 left over, which is that 1 over 6. That's how we get the 8 and 1 over 6. Does that make sense?
Yes, it does. Thank you.
No problem. Okay, let's jump back to these questions here. If we have anyone who is feeling good and confident, raise that hand. I'm happy to listen to some answers coming in. Let's see. Lorana, yes, hello.
Hello, ma'am.
How are you?
I'm fine. Which question
Good.
must I answer?
Can you answer 5.1 for me?
Yes, ma'am.
Okay. Put in something here to help.
First, I multiply 1 with 3, which equals 3.
Good. Okay, and then what's my denominator going to be?
5 times 4 equal 20.
Beautiful. That's all we're going to do. 100%. Got a mark in your pockets. Nice job. Okay, I see some hands up. That's great. I'm just going to wait a little bit just to give everyone a chance to give this a try. Don't forget to see if you can cross simplify. So I know with a lot of these ones you can't, but make sure you look to see if you can cross simplify. Dorian Cooley, remember all the lessons are recorded. Don't panic. I know I'm not Teacher Kirsty. I am Teacher Jen. I'm just here looking after you guys today. Okay, Itandile, can you help me out with 5.2?
Good afternoon, ma'am.
Afternoon.
Ma'am, we cross multiplied, which means that 7 times 1 was 7,
Good.
and 9 times 8 was 72, and yeah.
Beautiful. 100%. Nice. Good. You guys are finding these easy. That's awesome. Okay, let's do 5.3 nice and quickly. I see Mikle's hand has been up. Mikle, can you help me with 5.3?
Yes, ma'am. So 3 times 3 is 9, and then
Good.
4 times 4 is 20.
Yay! Nice job. Okay, so we're finding these easy. I'm taking in that we're finding them easy. Yes? Good. Okay. Let's move down. Oh, sorry. If you want to take a screenshot, please feel free to take a screenshot. Also, remember, if you're feeling confused about anything at any point, if you don't want the whole class to know, you're welcome to send me a private message. So it just sends to me. So it sends to the host. And then no one else will know what if you're feeling embarrassed about your question. Just me. All right. Let's jump to these ones. I'm wondering if we can, I actually think let's jump to these ones because I want us to start playing around with some things. Okay, so in these ones, I want you to be super careful and look for your cross simplification to see if there's things that you can do to cross simplify before you multiply. Okay, I'm going to give you a little bit of help here just because it's right at the beginning of our lesson. See if any of that can help. And then we can move on through. Hopefully we can get through addition and subtraction with fractions and maybe even division. We'll see how far we can get. But you guys are superstars, so I'm not worried. So why cross simplify? So the reason we cross simplify is because it keeps our numbers nice and small. And then we also don't need to simplify our fraction right at the end because whenever you give an answer as a fraction, you have to give it as its most simplified form. If we don't do that, then we don't. I'll show you an example here with 5.7. Let's do it in green. Okay, so as an example, so I'm going to do this 2 different ways. Ooh, sorry. That is a straight line. It's for all of you to know. Actually, I can't even deal with it. It's so far from being straight. Okay, so if we have a look at this, if we don't do cross simplification, we could say 2 times 6 which gives us 12. And then we could say 3 times 13, which gives us 39. And then we would be able to simplify that. So 12 can go, like, what number can go into both of those? Well, 3 can go into 12. So we'd have to divide this by 3. 3 goes into 12 4 times. And what you do to the top in a fraction, you have to do to the bottom. So 39 divided by 3 is going to give us 13. So we get to the final answer. It just takes us a little bit of time. But if we cross simplify, so if we said 3 goes into itself once and 3 goes into 6 2 times, then all we have to say is 2 times 2, which is 4, and 1 times 13, which is 13. And then that would be our final answer. So it just makes it a little bit easier. So where does the 3 come from? The 3 is because it's its highest common factor. So it's the highest number that can go into both of those. 3 can go into 12 and 3 can go into 39. You're welcome. Okay. I know I've got lots of excited hands here. I think I'm going to quickly zoom through these myself, not because I don't want to hear from you, because you know I love hearing from you. I just really want us to be able to get to addition and subtraction of fractions. So don't panic. There'll be lots of chances for you to share your answers as we move through this lesson. I'm just going to quickly zoom through these. But please remember, if I'm going too fast or too slow, just let me know. Okay. So 5 can go into itself once, and 5 can go into 25 5 times. And keep this color coordinated. 8 can go into itself once, and 8 can go into 16 2 times. Oh my goodness, we have a Lulu. That's very exciting. Okay, so that's our first step. That's our cross simplification. And then all we have to do is we have to multiply our numerators and multiply our denominators. So 1 times 2, which gives us 2, and 1 times 5, which gives us 5. All right, can I please see with an emoji, so a happy emoji or a party emoji, who got 5.8 and 5.7 right? How have these been going? Did we get them right? Did we get them wrong? I'm seeing hearts, thumbs up, great. Keep them coming. Beautiful. Okay, I'm going to give you 1 more minute to finish off 5.9. And then we can move on down. Look at you go. Okay, so if we have an answer of 40 over 55, is that the most simplified it can be? Can I simplify it further? Is there a number that can go into both 40 and into 55? Yeah, there we go. Nice. Good job, guys. So think about how we could use that. Think about how we could simplify it then. Okay, so 5 can go into itself once, and 5 can go into 10 2 times. So we're going to say 4 times 2, which gives us 8, and 1 times 11, which gives us 11. So we land up with 8 over 11. Now, if you did it the long way, so if you didn't do cross simplification, and you would have landed up with this 40 over 55, totally fine. Let's just write this in. gonna minimize this a little bit so I can fit it in. So if you have 40 over 55, then like you could see in the chat, there is a number that can go into both of these. 5 can go into both of them. So we're going to need to divide both of them by 5. What we do to the top, we have to do to the bottom. And then we would land up with 8 over 11. Okay. Screenshot away if you'd like to take some screenshots. And then we're going to jump into some mixed numbers. Please remember, if you're feeling confused at any point, ask away. I'm happy to answer your questions. The 2 hands that are up at the moment, were those to answer or were they to ask a question? If they were to answer, if you don't mind just popping them down for me just for a second. I promise I'll ask you to put them up, but if they are to ask a question, then keep them up. Okay. Amikle, how can I help?
Ma'am, may you please explain number 5.9, where it's the 40 over 55, please?
Okay, so the 40 over 55 is just if you don't cross simplify, if you keep them as your numbers. So you said 4 times 10, that would have given you the 40. And if you said 5 times 11, that would have given you the 55. So if you don't cross simplify, you would just land up with those numbers. And then you would need to simplify and you would get your final answer of 8 of 11.
Thank you, ma'am.
No problem. Okay. Cool, mixed numbers. Woohoo! I think let's be, how sneaky do we feel like being? Okay, I think let's just focus on these 2. So oh goodness, what has happened? We've gone to a whole different page. We went on a little journey. Don't worry, we'll get there. Don't stress. Okay. So I think that what we'll do here is I'm actually going to go over 5.17 with you, and then I'm going to let you guys try 5.18 by yourselves. Okay. Don't be scared just because there's mixed numbers. Totally fine. So whenever we have mixed numbers in a multiplication sum or in a fraction sum, we want to make them improper fractions. So that's our first go-to. So 7 times 5 is going to give us 35. 35 plus 1 gives us 36. So that's going to become 36 over 7. Okay. Times 4 times 5, which gives us 20. 20 plus 1 gives us 21. So we're going to have 21 over 4. And then our last fraction over here is we just have the 5 over 18. Now, the good news is that if this was in a test, you've actually already been, like, you've gotten 2 marks already, because you get a mark for changing these to an improper fraction. So even if you were so confused and you didn't know what to do, if you know how to change a mixed number to an improper fraction, you get marks. You never leave anything blank in maths. Always give it a try. Okay. Now we're in a situation where we need to start looking at cross simplification. But this one, I have a feeling we might be able to do quite a few things with cross simplification. The fun part of cross simplification is that you can use any top number with any bottom number. So, for example, I can use this 18 over here, and I can use this 36 because it's one bottom number and one top number. How many times does 18 go into 36? How many times does 18 go into 36? You can put your answers in the chat for me so I can see. Twice. Yes. Okay. So 18 goes into itself once, and 18 goes into 36 2 times. Okay. Cool. Now we have another section here that we could play with. There's 2 more things that we could do, but let's just do the one sort of more obvious one first. What numbers do you see here that we can play with cross simplification? I'm going to need one bottom number and one top number. Which of these can we play with? Have a look at them. So we've got the 7 over here, and we've got a 21 over there. How many times does 7 go into 21? 3. Good. Okay, so 7 goes into itself once, and 7 goes into 21 3 times. Okay, when you get to this point, you can actually carry on cross-simplifying, but often what I found with my students is that they make mistakes because there's numbers everywhere, and so they make silly mistakes. The easiest thing to do at this point is to actually just write down what you've got so far. So we have 2 over 1. So we're just going to write that as a fraction. Okay. Then we've got 3 over 4. That's our second fraction. And then we've got 5 over 1 as our last one. Looking at these 3 fractions now, is there any cross-simplifying that you can see that we could do with any more of these numbers? What further cross-simplification could we do? Have a look at them carefully. Good, the 2 and the 4, excellent. Excellent. We've got this 2 over here, and we've got this 4 over here. So we're going to say, well, 2 goes into itself. Oh, goodness, I'm highlighting now. 2 goes into itself once, and 2 goes in. Oh, let's change that color. Sorry, guys, all over the place. 2 goes into itself once, and 2 goes into 4 2 times. And then it just makes it a little bit easier for us to see. So you could also have done it in this top set because you've got the 4 and the 2. But yeah, just easier when the numbers are a bit clearer. Then all we have to do is we multiply our numerators and we multiply our denominators. So 1 times 3 is 3. 3 times 5 is 15. So we're going to have 15 at the top. And at the bottom, we've got 1 times 2, which is 2. 2 times 1, which is 2. So we land up with 15 over 2. Okay. Itandile, how can I help?
Ma'am,
Yes.
I didn't understand your method, but then
Okay.
I got the same answer as you.
Okay. Can you tell me which way you did it? Did you multiply all your tops over all your bottoms?
Yes, ma'am. As if you change when you remember your first step, I changed them into improper fraction. Then I times bottom by bottom, top times top, and it gave me 3,780 over 504. And then I simplified it, and it got me 2 over 15.
Okay, so if you don't do cross simplification and you just multiply your tops and your bottoms, it's totally fine. And if you have a calculator in your test, it's absolutely okay to do that. Sometimes in fraction tests, they don't let you use calculators, or they'll say, do this without a calculator. And whenever they say in the instruction, do it without the calculator, what they're secretly saying is show cross simplification, because you have to, then we don't have to deal with those big numbers. So what you've done is absolutely right. It's the way of doing it without cross simplifying. But if we cross simplify, we just end up with the smaller number earlier.
Yes, ma'am.
Okay.
Okay.
And Michle, do you have a question for me?
Yes, ma'am. Ma'am, may you please do number 5.17 again, please?
Sure. I will talk through 5.17, and if you understand 5.17, then please feel free to start working on 5.18. If you don't understand 5.17, then you can listen while I am working. Okay, I'm just gonna get rid of all of this quickly. Okay, so first step is we want to make everything improper. So we got to make them improper fractions. So let's keep that step the same. So we're going to say 7 times 5 is 35. 35 plus 1, that's our plus, that's our times, gives us 36. So we're going to have 36 over 7. That's our first number, or our first fraction. Okay, times 4 times 5 is 20, plus 1 is 21 over 4. Okay, times, and then we have our 5 over 18. Now, if you feel stressed, so I'm going to show you a whole bunch of different ways of doing it. So you can do it the way that we just did it, where you do your big cross simplification. If it stresses you out though, to like jump from the 30, like the 36 and the 18, don't panic. You can just look at these first two fractions and see what you can simplify. So we could say, okay, 7 goes into itself once and 7 goes into 21 3 times. All right, cool. We can look at our 36 and the 4. 4 goes into itself once and 4 goes into 36 9 times. Cool. So we land up with 9/1 times 3/1. Let's just write out these fractions. So 9/1 times 3/1 times 5/18. So if you did it this way, you're also absolutely 100% right. Okay. From here, we could see, well, we can do the 3 and the 18. So 3 goes into itself once, and 3 goes into 18 6 times. So we land up with our 6 over there. And then we're going to have to do the 9 and the 6. So we're going to have to simplify again. So we're going to say 3 goes into 6 2 times, and 3 goes into 9 3 times. So now we land up with 3 times 1 times 5, which gives us our 15, and 1 times 1 times 2, which gives us our 2. So lots of different ways of going about this. You can do cross simplification. You cannot do cross simplification. You can do a whole bunch of different ways. If you get to the end point, that's perfect. The most important thing is that you change them into improper fractions in your first step. That's the most important thing. And remember, when you cross simplify, it needs to be one bottom and one top. Oh, sorry. Emily, I didn't realize. Okay, and when you are feeling a little bit braver, let's go through 5.18. I think for 5.18, let's kind of work through it together, but like in the chat. So I want you to give me answers as we move along in the chat. Okay. The first answer I would like is, what is the improper fraction of 2 and 1/7? What is that going to become? Nice job, guys. So 7 times 2 gives us 14. 14 plus 1 gives us 15. So we're going to have 15/7. Beautiful. Times. What is 1 and 5/6 going to become? Yay! 11/6. So 6 times 1 is 6. 6 plus 5 is 11. So we're going to have 11/6. And our last fraction, 2 and 1/10. Tando is on a roll. Yes, I love it. 21/10. Okay, so if you are at this point, guys, you have got 1, 2, 3 big fat ticks on your mark, like on your work right now, which is awesome. Yay. Okay. Sure. When we're looking at this, who can give me, so there's lots of different ways we could do this question. Yes, Zande. Oh, you're just ahead of my even speaking. Yes, 7/21. So there's one bottom and there's one top. So we're going to simplify those two. So let's not use red because we're marking in red. Color should we use, guys? I feel so torn. Okay. So, oh no, I'm in highlighter mode. I'm going through the most here. Okay. So 7 goes through itself once and 7 goes into 21 3 times. Okay. Who can give me another suggestion? Let me have a look on our board. Who suggested? 15 and 10, absolutely. So we have one top and we have one bottom. Beautiful. So for my 10 and my 15, what's going to happen there? What number goes into both of those? 5. Good. Good. Okay, so 5 goes into 10 2 times and 5 goes into 15 3 times. Now, at this point, I'm going to rewrite our fractions just so that everyone can see what's going on, because there is still something we can do, but I just wanted to be clear to everyone. So we've got 3 times 1 times 11 over 6 times 3 over 2. And by showing our cross simplification over here, we actually would have already gotten 2 more marks in our test for showing that we know how to cross simplify. So now we're at this last step. What are the last numbers that I can use here to cross simplify? I got one more set that I can use. Good, the 6 and the 3, excellent. Okay, so with our 6 and our 3, 3 goes into itself once and 3 goes into 6 2 times. Then all we have to do is we need to multiply the tops and the bottoms. So 1 times 11 is 11. 11 times 3 is 33. So we're going to have 33. And at the bottom, 1 times 2 is 2. 2 times 2 is 4. So we're going to have 33 over 4. Please tell me how this one went. Did we get it right? Did we get it wrong? Did we get halfway? Did we get medium way? Give yourself another mark over here for cross simplifying and then give yourself a mark for your answer. Yay! I'm glad, Amikle. Halfway, not bad, Bree. Halfway is better than no way. Remember in maths, I know that I've already said this in this lesson, you cannot leave anything blank. I always want you to try something. So if you see a question like this and you panic, we're just going to breathe, we're going to woo-saw it out, and you're going to at least do that first step. And I promise once you've got those improper fractions, you'll be like, oh, I know what to do. I'm a smart one. I know what's going on. Good job, guys. Often they look scarier than they are. And as soon as you get started, it's fine. Cool. Okay, if you want to take a screenshot, please feel free. And then we're going to just jump into, I think, addition is next. Okay, so I'm actually going to jump over that and we're going to talk through these ones. So who knows from in class what the most important thing is when it comes to subtracting? When it comes to subtracting or adding fractions, what's the most important thing? The 2 that we have on the screen at the moment, they've already got it, if that's any help. Okay, yes, we only add the numerators. That's a good point. But yes, Amikle, between Tano and Amikle, we got to the perfect answer. We only add the numerators, but the denominators have to be the same. Okay, so here we've got a 7 and we've got a 7. Because our denominators are the same, that means we are allowed to add our numerators. So then we can say 3 plus 2, which gives us 5. Okay. And our denominator stays exactly the same, over 7. So if the denominators are the same, then we are allowed to add the numerators. But if our denominators are not the same, we are not allowed to do that. Sorry, I did not like how my 5 came out. It was irritating me. Okay. All right, let's have a look at 2.1.2. So again, our denominators are the same. If you get an improper answer, generally, it's 100% fine to leave your answer as an improper fraction in high school. But like I said to Mikle earlier, or maybe it wasn't Mikle, someone asked me this earlier. Sometimes some teachers are quite strict about what they want. And so if you have a teacher who is quite strict about wanting it as a mixed number in the end, then make it a mixed number. But otherwise, an improper answer is perfectly fine. Okay. Cool. So our denominators are the same, which means we can go ahead. So we've got 8 as our denominator. Beautiful. At the top, all we're doing is subtraction. We're saying 5 minus 3, and 5 minus 3 is equal to 2. So we'll end up with 2 over 8. My question to you is 2 over 8 as simple of a fraction as it can be? Amikle, yes.
Ma'am, you can divide it. So 2
I
divided by 2
can.
is 2, and then 8 divided by 2 is 4.
Beautiful, 100%. Okay, I can divide both of those by 2, which means I'm going to land up with an answer of 1 over 4, 100%. Remember, your answers and fractions always need to be the most simplified version. Okay, let's go to 2.1.3. It's going to move it along over here. I'm going to keep those on the screen so you can see them. Okay, so again, it's got the same, they have the same denominators. We don't have to do anything fancy. They've got 5s, so it's nice, happy, easy days. So we know our denominator is going to be 5. Awesome. And then we just look at what our order of operation is. It's a plus. So we're just going to say 3 plus 1, which is 4. And we just end up with 4 over 5. Okay. If you would like to take a screenshot, you're welcome to. We're going to try and jump to some trickier ones. You are all doing so well. I'm very proud of you all. Don't be scared to ask questions. Okay. So these ones look slightly scarier because we've got more than just 2 fractions, but they're not so bad because their denominators are all the same still. So we don't need to do anything fancy. You should be able to go through these ones nice and quickly. Like just kind of zoom your way through them. And you're welcome to pop your answers in the chat once you have figured them out. Don't overthink them. Don't be stressed by it. If you want to do it step by step, you're welcome to. So like here, you could first add those if you would feel more comfortable. Totally fine. Yes. Okay. First answer. Beautiful. 4 over 7. I think quite a few people will feel more comfortable to do this in 2 steps. So I'm just going to do it in 2 steps here so that you can see. We're going to keep that denominator the same. And then 3 plus 4 gives us 7. There we go. I love how you guys are working together. Like you get answers and then you help each other out. 5 over 5, which is absolutely equal to 1. Beautiful. Beautiful. Okay, and then your last one over here, give it a go. So I'm going to add these 2 fractions first. So 11 plus 4 gives us 15 over 7. And then we're going to minus 6 over 7. And what answer did we get? Yay! 9 over 7. Woohoo! 100%. Okay, screenshot away if you'd like. Let's get to the slightly more interesting questions. Oh, sorry, Mikli, I didn't see your hand. How can I help?
Oh, ma'am, for 2.1.6.
Mm.
For the 9 over 7, ma'am.
Yeah.
Can't you like simplify it to be 1? Wait, yes, 7 goes into itself once, and then there's a 2 left over.
Yeah, you absolutely can. So if you want to make it into a mixed number, you can 100% leave it as 1 and 2 over 7.
Thank you, ma'am.
No problem. Okay. I know you guys know how to do improper fractions. I want us to get into some fun questions. Let's look at these guys. Okay. Always fun. Okay. So I'm gonna do 2.3.7 with you, and then I want you guys to try 2.3.8 by yourselves. But we're gonna kind of work through 2.3.7 together. So I'm gonna do it for you, but with you, if that makes sense. So in 2.3.7, now we have a situation where our denominators are not the same. We have a 3, we have a 6, and we have a 12. So now we have to figure out what our lowest common denominator is. So we need to figure out, of these numbers, what's the lowest one we can go to. The first thing that you kind of want to do is see if any of these work. So for example, 12, 3 goes into 12 and 6 goes into 12. So then we know 12 works. Remember, your math teachers are not trying to trick you. They're trying to help you. If you look at the question like 2.3.8, we've got the 3 and we've got an 11. Now, 3 can't go into 11 and 11 can't go into 3. So then we're just going to multiply those together. So we're going to say 11 times 3 and we're going to get 33. But in this one, we can say, well, 3 goes into 12 and 6 goes into 12. So we know our denominator that we're wanting is 12. And once we've got that first point, that's very helpful. Hold on, I think that's going to stress you out. Let's leave these as singles. Okay. So I'm going to leave this as 7 over 12 because I'm not doing anything to it. And we're going to do something to these other fractions. Now, remember what I said earlier, what you do to the top, you have to do to the bottom. If I wanted this 3 to be a 12, what would I have to multiply it by? What would I have to multiply that 3 by to get to a 12? 4. Excellent. Good. Okay, so 3 times 4 gives me 12. What we do to the bottom in a fraction, we have to do to the top. So we're going to say 1 times 4 as well. And so we land up with 4. So we have 4 over 12. So that 1 over 3 has become 4 over 12. The 7 over 12 is staying 7 over 12. What do I have to multiply the 6 by to get to 12? 2. Good. So what I do to the bottom, I have to do to the top. So I'm going to say 1 times 2, which is 2. Now everything has the same denominator. So if I was getting marked for this in a test, I'd get a mark for that first fraction and I would get a mark for that last fraction. Now that my denominators are the same, we can just add and subtract. So if you find it easier to work with the first two, we can do that. So 4 plus 7 gives us 11 over 12. And we are subtracting 2 over 12. And then 11 minus 2 is going to give us 9. So we have 9 over 12. And what is that going to simplify down to? 9 over 12 is not a simplified fraction. Tanda to the rescue in the chat. Absolutely. I can divide both of those by 3. So 9 divided by 3 gives me 3. And 12 divided by 3 gives me 4. So I'm going to land up with 3 over 4. Okay, mark-wise, you would get another one for getting to the 9 over 12 and another one for your simplified answer. Okay, give 2.3.8 a try for me. Don't be scared. I'm going to keep 2.3.7 on the board so you can see what I did. Yes, Mikli, how can I help?
Ma'am, so
Yeah.
for 2.3.8,
Mm-hmm.
so since 3 can't go into 11, do we have to, can we like, so like, since 11 times 3 is 33, can we also like, for the 8 over 11, times the 11 by 3, and then times the 8 by 3, and then get the answer?
Absolutely. That's exactly what we're going to do in the situation. So we're going to times that by 3, and we're going to times that by 3, and then we're going to times this by 11, and the same you're going to do here, and then you're going to do something there too. I'm going to help you guys out a little bit, not a huge amount, just a little. See if that helps anyone. Oh my goodness, guys, look at the time. Our lesson is almost over. How did that happen? Where did the time go? There it goes so quick. Okay, so that's 8 times 3. That's going to become 24 over 33. Now be careful with fractions. Fractions are sneaky. When it says in a test to do this without your calculator, you can use your calculator to help you. So it's just like I could use my calculator to say what is 8 times 3 if I needed help. But if we jump straight from our question to our answer and we don't show any of these steps of working, we're going to get a big fat 0 on our test because it shows that we don't really understand what we're doing. So just be careful when it says without using a calculator, or if it says show all steps of working, we have to show every single step. Okay. So now here, we're going to times this by 11. So we're going to land up with 22 up here. Whoop. And these two, we are going to times by 3. Times by 3, times by 3. So again, we have 24. Okay. So 24 plus 22 gives us 46. 46 over the 33 minus 24 over 33. Nice job, Bree. Remember, making mistakes in math is good. The more mistakes we make, the better we learn. 46 minus 24 gives us 22. We have 22 over 33. What number can go into both of those? Tando, yeah. We can divide both of those by 11. Bree, yeah. And so our final answer is going to be 2 over 3. Okay, so now if you did this in class, so if you've got this on a piece of paper in front of you, let's just see where we'd get marks. We'd get a mark for getting all of those to have the right denominator. So we're sitting on 3 marks there. Then you would get a mark for getting the 22 over 33, and you would get a mark for getting the 2 over 3. So you're looking at 5 marks here. Do we have any brain buffs who got 5 out of 5? So you have got where all of my ticks are, you have got those. You have a headache. Oh no. Luckily you can turn your brain off for a little bit after this lesson. Do we have any brain buffs to learn with getting 5 out of 5 for this question? Let me know. If you didn't, if you got 4 out of 5, or if you got 3 out of 5, tell me. Yay! We've got 5 out of 5. I love it. Nice job, guys. You did awesome. Woohoo! Okay, so sadly, we're not going to have time to do another question before the end of this lesson. But what we can do, because we have 3 minutes, let's zoom over here. Okay. We're gonna kind of like in 3 minutes. So we're gonna basically like do this at like super speed. That's what's gonna happen. So we're gonna do 2.3.4 together, but at super speed. We're gonna see how far we can get. I believe we can do this. Okay, so let's have a look. First things first, we've got fractions. We've got to change our mixed number to an improper. So my question to you is, what is that fraction going to become? Go, lightning speed. Let's go, let's go, let's go. Pop it in the chat for me. 16 over 5. I love it. Let's write it in. 16 over 5. Okay, 16 over 5 plus 7 over 10. Okay, while I'm writing this, I want you to start thinking, what's going to be my lowest common denominator? What's going to be my lowest common denominator? What is my lowest common denominator? Okay, so 30 could work. Yes, good. Okay, so 5 can go into 30, 10 can go into 30, 15 can go into 30. Beautiful. Triple speed. What do I have to times 5 by to get to 30? Yes, good. Okay, what do I have to times 10 by to get to 30? What do I have to times 15 by to get to 30? Woohoo! Look at you guys zooming through this. Okay. Okay. What is 16 times 6? I think it's 96, but I don't have a calculator on me. Oh gosh. Well done, my brain. Very proud of my brain right now. Okay, 96 over 30 plus 21 over 30 minus 8 over 30. Okay. What is a 96 plus 21? 96 plus 21. Beautiful. 117 over 30 minus 8 over 30. That looks more like an infinity sign than an 8, but you know, we do our best. Okay, what is 117 minus 8? (117 minus 8). We get some weird answers. But yes, absolutely 109. 109 over 30. Woo! Guys, we did that whole sum in 3 minutes.